Hi, hello everyone. So any project will have few parts, like you need to do first pre-layout simulations, all the analysis, then you need to make a layout, then post layout, and then the sign off. So for this inverter project, in our pre-layout simulation, what we're gonna do, we're gonna see the VTC of our inverter. I'll explain everything, what is VTC and those terms. Then I'll see the noise margin, the noise performance of our inverter which we have designed, and also the rise and fall time or the speed of our inverter, and then the most important part, and that is the power consumptions of our inverter. After all things are done, then we go to the layout, we construct our layout, we do the extraction, those things, and there again we do the simulation, and we'll try to see that is our pre-layout simulation result, and after creating the layout both are matching or not, and if they are not matching, then what are the concepts, theory behind that. And also the main objective of creating this playlist is that you should have your Git repository where there should be minimum 10 VLSI project which you have done on your own, not like you have copied GitHub or Git repo from some other place and you just copied to your, and you are saying, hey, I have done this thing. So in every episodes I'll try to tell many things apart from doing only the projects, so that you become capable of debugging any issue in the future. And also these videos would be on parts, because if I want to make a video of pre-layout, layout and everything of CMOS inverter project in one video, it will be 2-3 hours. It is tough for me also to shoot in one day, and also for you to consume it in one day. So better would be slice it down. For example, pre-simulation we have many steps, so for each step I'll make a 15 or 30 minutes video, and I'll try very fast, like every day. Probably not possible, but I'll try. So likewise we'll get a chance to make our hand dirty and actually learn the concepts, theory through the project. So if these things are exciting and you think that hey, I'm doing a good job, then it's your responsibility to like every video. If possible, share with your friends, best buddy, and this thing will really help me. So let's get back to the project. So first thing first, let's make a new directory for today's project. So 2. So after you make any of your directory, then we need to invoke our scheme, right? But before you invoke your scheme, you need to actually connect it to your PDK, which is your Sky 130. If you have seen my episode 1, you already know what all about I'm talking, so I hope you have seen. So to connect them, actually we need to copy the scheme RC file to this directory which we have created. So let me get that path. Yeah, I got the path. So cp and then the same location, so dot ls, and yeah, scheme.rc file got copied, and which means that if we invoke scheme from here, so let me try it out. You can see, if you see this window, then that means your schematic capture tool got integrated. But let me close it, because I will invoke my scheme not from this terminal. This is by default terminal available in your Linux, but in my first video also I have told you that we will work on Xterm. There are many reasons, but yeah, install Xterm. In episode 1 I have already shown you how to install it. So let me invoke it first here, and then we will do all other works in Xterm only. So let me minimize this window. So in Xterm, if we wanna see are we in the correct directory, then you can write pwd, same in other terminal also, and yeah, we are at the directory which we have created. So from here I will launch my scheme and then person, and scheme is here. So let me make it smaller. So here what I will be doing, creating a new schematic, and anytime you have created your new schematic, then please save it, otherwise you might lose everything. So come save as, and here just change the name. So let me give it name as DC sweep. Why I'm giving it name DC sweep? Because we're gonna do DC sweep, and this is actually the first step before any project, mostly for any analog project. Today we're gonna do the digital one, the CMOS inverter, but I will show you this DC sweep so that you can appreciate. Actually it is very easy to do, so you can appreciate how XSCIM is working, simulation, everything. And after this step 1, which is optional for digital most of the case, for analog you need to do, it's mandatory. After that we'll go to a step 2, which is to see the VTC curve of our inverter, to see how if we increase decrease the width of our PMOS and MOS, how those things are behaving, noise analysis, power finding, delay, fall time, delay time, those things we'll see. So gonna be interesting, but first do this task. So yeah, I have saved it. So I will, let me do what, let me analyze our NMOS here. I will do it for NMOS, you do it for PMOS also. So for NMOS, if you remember, like to get any symbol here, what we'll do Shift I. So here we'll go inside our XSCIM, and here inside this directory we have all our primitive devices, NMOS, PMOS, everything. And here I'll search NMOS. NFET, I guess, yeah, NFET, and you will see there are many type of NFET, right? If you have time, you can, like for example, you start with one of them, do its characteristics, then you can try with other, you can do the experiment. But for our case we'll choose this one, simplest one. There are many other flavor like low VT, high VT, and those things actually, like if you need a low power device, right, then mostly we use high VT devices, right, to minimize the leakage current. But high VT will reduce the speed of your circuits. So for a high speedy device, we gonna use a low VT. So that's why there are many different flavors are there according to your specifications. But for now we'll do the most simplest one. We'll take this one, NFET, this one. And let me and bring it here and just place it. Done. After that we need to have two voltage sources. If you remember your books, in any books where NMOS, PMOS theories are there, you see there are curves, right? Input output, those curves are there. But to get those curves we need to have two excitation, and that is one in the gate which is called VGS, and another at the drain which is called VDS. So for that I'll again click Shift T, and all the voltage sources, everything's are residing not inside your Sky 130 folder, but into your default XSCIM folder, which is this one with the red color. Go inside devices and type V source, I guess, yeah, V source. So I need to, so I'll get one, and then I'll copy this one. So I will C and copy. I'll just select it, and then I'll press C in my keyboard, and see it got copied. Now I'm not dragging, I'm not touching anything, no key are pressed, I'm just getting it. So don't drag it. Let me revise it again, how to copy anything. Actually move also you can do. Move means you are moving it, not copying it, but same. First you need to select the things which we're gonna copy or move, and then C for copy in your keyboard and M for move. So C and C, it is moving, so I'm placing it here. Okay, so let me give it a name to as BGS. And one thing very important, and that is your this thing, spice is not case dependency, like capital VGS and small VGS all are same. Okay, and let me give it 0. Why 0? I'll tell you later. And this one I'll give VDS and value as 0. So why I'm giving it 0? Because I'm gonna do the DC simulations here, right? And there are many type of simulations we have: DC, SE, transient, pole 0, then sensitivity probably, and ngSpice, because all the simulation will be doing in ngSpice environment, support everything. Actually there is a very nice tool to learn about ngSpice, to know how it is simulating actually all those like behind the scene, behind the stage things, what is happening. If you are interested, I'll show you that there is a manual, you can follow that. But ngSpice support many type of simulations, and out of all those simulation, the three, DC, SE and your transient are very important. SE is important for analog mostly, transient we do mostly in the digital, but DC we need to do for all type of circuits. But what's the difference? So DC is like, it is not time dependent. If you give a signal, for example 1 volt excitation without considering any time dependency, for example your capacitor, inductor are time dependent things, right? But if you do DC simulation, then your capacitor will be open circuited, your inductor will be short circuited. So that's the DC. AC is mostly depending on the frequency analysis. If you design your amplifiers, those things, then you need to know inside which frequency limit your amplifier is working. So that time we do AC simulations. And transient is like DC simulation only, but in the time dependence format. Like, hey, give this voltage, but for this much of amount of time dependency is there. So we need to have an initial condition to solve our capacitance and inductor formulae. So initial condition will be like we will get out of DC simulation only, and then the simulator will run the transient simulation. So if you want to do transient simulation, in behind the scene actually DC simulation is going on first and then the transient simulation. But here we will do a DC simulation. Why? Because we want to see I will increase my BGS. So if I increase my BGS, if you remember your MOS theory, then and there is some, for example I have given some VDS here, there is significant, for example maximum supported by it is 1.8. so I have given this circuit 1.8 VDC. Then if I keep on increasing my VGS, first of all I'll have a zero current in the ID. This is your drain. In the drain terminal I'll be having zero, and the anytime it cross the VTH, the threshold voltage, then only curve will shoot up. Okay, but here what I'm gonna do, I'm gonna increase my VGS from 0 to some voltage, but I also want to see for different VDS. So different VDS you can give, for example 0, 1, 2 up to 1.8, and that's why here in the VDS I have given 0, because if I give it 1.8 that is also fine, but that is fixed. But I wanna simulate it for different values of VDS. So that's why if you give 1.8 there is no error, but for now let it give it 0 because this have no significance here. Let me connect it and I'll show you how I will make this VDS as a variable, this BGS also how I'll make it a variable. Okay, so I need here the, to make it more perfect, let me move it this side and let me connect. So for wire you just need to have your cursor here, W, and then click W and then click and W to like get the corners of the wire, and then this need to be connected here. So let me move it little down. These are the like just to beautification, but it look good. So to moving you just click M and then and then click and wire. So I have connected it. It connected, and then I need the ground terminals here. So I'll again do Shift I, and in this Xscheme library only I have the ground. So GND and ground is here. So get it here, one ground here, and then click C, copy, bring it here, click C, copy and bring it here. And one very important thing, and that is your body terminal of NMOS need to be connected to the ground. Most of the time we miss it, like whenever first time we are doing this thing. So again where W and it's not connecting. It's connected. Right, I think I have done everything perfectly fine. And one thing you have observing here, I haven't changed anything inside my NMOS. Is by default. So by default is W is 1, length is 0.15, and these things are the parameters, okay, defined by our foundry. We can change it, we need to see which we can change, but hey, most of the time we don't need to change them. We mostly work on W and L. And for digital circuit we also don't touch L. Most of the time L is the minimum possible things, and if it is a 40 nanometer technology then we'll keep N to the 40 nanometer only, lowest, because lowest the L, fastest the device, everything will be perfect. So that's why. And all the design things, if you heard about like design a for example NAND, so the configuration of NMOS and PMOS are same, But what does design means? Design means playing with your W. You play with your W, you make your that circuit run fast or power efficient and everything. So mostly we keep on changing W, but here we are not changing it. After this thing is done, I need to tell my schematic simulator that, hey, what you gonna do, like what we gonna do here. So for that we need to bring one of the window here, which is called code window, where we'll give him or her the library access, like from where you'll get the definition of this, because this is coming from Sky 130. So I need to give the path here, right? Then only in the netlist I'll get a definition of it. And then also I need to tell him, hey, him or her that, hey, I am doing a DC simulation here. And also I haven't defined the steps of VGS and VDS, so everything I need to define, and we define everything inside our this block, and this is called code shown, and bring it here and keep it somewhere here. So go inside, and here everything you can keep it as it is, or if you want you can write like DC simulation. That's are optional, but in value here we'll be defining, and anything we define here will define under the quotation. So what is happening, anytime you make the netlist of it, and why netlist, everything I have explained in episode 1. So anytime you make the netlist of it, the things you have written in the inside the value will get embedded to that netlist. I'll show you, I will explain the netlist also, what line what signifies, so don't worry. So here first of all I need to give dot lib. Again, these everythings are explained in the manual of your ngSpice. This here I'm doing everything in the Spice language. ngSpice, as name suggests, supports Spice, so we need to know a little bit about Spice, and there is a huge manual, 300 or 700 pages. You don't need to read it, but anything, for example I am writing it dot lib, so you go to that manual and search dot lib, what are the different things you can do with dot lib, or what are the exact meaning of dot lib, and then only in future you will be independent, like you don't need other people's support. Like now you are taking my support, but if you keep on doing like these things, that here every line, for example here I have written in future probably I'll be using control here. Okay, so you need to know why I'm writing, and from where you can know it from the ngSpice manual. Let me show you actually where the ngSpice manual, and here is your ngSpice manual. Check the description of this video, I'll give you the link. And for example, and great thing is about this PDF is very like it is designed very perfectly. In the side only you will get all the things, and for now I have used dot lib. So let me just search here, control F, dot lib, and dot lib. See here it's written in like short form include library, but if I go to 2.8 in detail everything is written. So you need to get those things, everything I can't explain, but by this way you can learn about ngSpice more. There are many things, you don't need to know it in day 0, and also it's not the correct way that, hey, let me read it first full and then only I'll go and I simulate. This also not a good smart idea actually. The smart idea is start doing design, anytime you face any issue then you come here. But for example you faced any issue and the solution would be using dot param, but who will tell you that, hey, you need to use dot param? Probably I will tell you in my future video anytime like issues are coming. But another source, and that is your Google. In Google there are solution already, you just need to be patient, search with using the perfect questions and you'll get the answer. Okay, so this is the library link which you need to use actually. And after that, and one thing is very important, and this part would be same in your system also. If you are following my episode 1 and you have installed everything, then it will be the same. But for your convenience, what I'll do, I will share the netlist actually, so that you can copy and directly paste it. Otherwise if you type it, sometime you might type it wrong and you won't get the answer, and in the beginning you also don't know how to solve it, right? Okay, after that I need to define, right, what are my VGS and what are my VDS values, and also I need to define the simulation, what type of simulation I'm gonna do. So I'll be doing DC simulation. See, every time all the commanders start with dot command, so it's a dot DC. So I'm telling my simulator, hey, it's a dot DC DC simulation. And in DC simulation, what you do, you vary my VGS starting from 0, go up to 1.8 volt, and in a step of 1 what called milli, right? And also you vary my VDS start from 0, go up to 1.8, and in a step of probably 0.5. So here one thing is significant, and that is the first one would be your DC sweep. Okay, so what it will do, it will sweep this one for sure. It will start from 0 and it will go up to 1.8, and it will do that thing for VDS equal to 0 for first time, then for VDS equal to 0.5, then VDS equal to 1, likewise. Okay, and after that I need to save everything. So save all and dot end. Actually here also I will be having a dot save. And it is also better to have pins here, because whenever we gonna draw our graphs, that time those pins will help us. So let me get the pins. So for pins, again go inside device, like the by default scheme, and here write lab pins. So we have lab pins here. Okay, connect one here and connect another, probably. And after that, the next step is that go to option, because by default your netlist window won't be coming, but we want to see our netlist, right? So one thing would be show netlist window, select it, and then again go to option and select like which kind of netlist you're gonna prepare, and that is Spice netlist. So I think it is selected already. If it is not selected, it will show some error that hey, select the language in which you're gonna get your netlist. That time select Spice and this one show window. After that, the next step is click netlist, and see we are having a netlist here, but it is faulty. Why? Because I got another window here, and that is the error window. And in the error window, it is telling me that hey, your VGS is shorting with XXX terminal, and anytime you are shorting, anything is open, anything is not defined, it will show here. So let us fix it. We got our netlist, but again, getting a netlist is not the perfect thing. It should be errorless. So I'll come here. Yeah, see something happened here, so let me cross it. VGS, and I think everything is okay. And then again netlist, and this time I don't got that error window, so that this netlist is perfect for me. And here let us see what netlist actually include. In our netlist, and everything, these things also are explained nicely in your NDSpice manual. Like if you search dot subcircuit, everything you will get there. So what it is doing, it is making, it is like a function in our general language, if you know. So this is like a function definition kind of thing, and that is your function name, but here it is a module name. And here what we are telling that here we have a MOSFET, and that is your MOSFET. Anytime X means we are using something from outside of this netlist, and M1, all the MOSFET and MOS are defined by M. If it is R, then it is a resistor. So M1 means it's a MOSFET, and then it's connected between VDS, VGS, and ground, because it is a 4 terminal VDS, VGS, ground, and ground. And then this M1 get its value from this model file. And how it is knowing that it is getting from this model file? Because of this library inclusion. See, it got all the value from the model file. So we need to include this library. That's important thing. After that, we have a terminal and VDS. It is between VDS and VGS, and the value is 0, because here we have defined it at 0. And same is true for your VGS, it's 0. But I have overwritten it with this code. See, here it is written begin user architecture code, and that is defined in this place. So I have overwritten it, and in the overwriting, what I am doing, in by default is 0. I have defined it 0 here, but I have overwritten it there and saying him or her that hey, it's not 0, you need to change it like this, You need to change it and then do my simulation. Simulation is still not there, but this is your symbol, like this is symbol, but if computer need to understand, this is the codes, and these codes will further compile to 1.0 format so that our computer will understand it. Okay, so and after that we will simulate it. So simulation started, and I think simulation is done. After simulation is done, there are a few commands which you can use every time, and that is one is display. So display will show you all the plots available to plot. So we have vsweep, vds, vds branch, and here types are also written. It is a current, and then vgs is the voltage, and those things. And so for example, let me plot this one, not this one, vgs. So I'll write plot vgs and see. This is how we are doing, right? We have started from 0 and we are going up to 1.8. So now let's plot the id currents here, and id is actually this branch, right? So it is vds branch. So we have this vds branch, so we'll plot it, plot vds branch. And probably this is not similar to you are not familiar with it, but you will familiar with little after if I insert minus here, because this is a current, right? Current had their conventions, so probably currents are coming from here, so that's why it's minus. And I want to see in the conventional way how we gonna like we used to see in our books, so that's why I'm plotting it in minus. And see, you have seen this many a time, right? And this is your VGS. You are varying your VGS for different VDS, right? And if you want to know what is your threshold voltage, then probably the time you are start getting your current, so it's around 0.6 something volt. And also you can plot our ID dependency with VDS for different steps of VGS. So for that, what we need to do, we need to change here. You come here, this one, we'll just interchange our VGS and VDS, because first would be the sweeping value. So this time I'm gonna sweep VDS, and I want to see it for different values of VGS. So I have changed it. After changing, do the netlisting again, save it, and after that if you click simulate, it won't simulate, because in the background your simulation window is already there. So there are some shortcuts, I don't know, but for me how it works, it is I need to close it every time for the next simulation. So I'll close it and then I'll simulate it again. There are some environment variable or something by which this issues is won't be there, but I don't know. If you know, comment it down. And it is done. And after doing, let display what are the plots available. These are the plots available. We wanna plot our VGS, VDS, our ID current. So plot VGS. Again, it's not familiar to you, so I need to insert a minus here, -1, and then started and see. And I hope any book you open on the theory, you will see this curve. So, and what's the significance of this curve? In analog there are a lot of significance of this curve, and it is what we do. See, this way it is your VDS, you are increasing your VDS, and you are seeing it for different values of VGS. So if VGS is, for example, 0.5, then you will get this curve. If it is something, you'll get this. If it's something else, you'll get this one. So for analog, actually we need to select our operating point, or exact terminology I'm forgetting. It is like a load line we draw actually. So that time we need to fix the optimized value of VGS for which the amplifier will work. So for example, we want to stay around this curve. So that means in our circuit we need to select a VGS which is this, and that is your 1 volt. So then we'll give VGS as 1 volt and we'll vary our VDS. So anytime I'll do a project on analog, like designing a op-amp or something, then you will appreciate. But it is a very important task for any analog project. So with this, step 1 is completed, and tomorrow I'll again release another video where I'll do the next step, and that is the VTC, and then day after tomorrow. Let's see how fast I can do. But for today, your task is that I have done it for NMOS, you need to do it for PMOS. Please write down any issue you're having. I will try my level best to help you to get these things for your PMOS also. So before saying bye, please don't forget to like this video, and I'll see you tomorrow. Bye bye.